onto functions. Another name for onto some functions is surjective. Definition. Recall that we define the range or image of the function as follows. R of f, if f is our function. Okay, look. We define G, domain of G, subset of R into R. This is our function. The range of G, R of G, by definition, is the collection of all y in R, such that we can write y as G of x for some x in the domain of G. This is the definition of range of the function. Please don't forget this. Now, a function f or g, a function g from domain of G, subset of R into R, is said to be surjective. That means it is onto. If for every y in R, there exists x in the domain of G such that we can write y as G of x. A function that behaves like this is said to be surjective on this codomain. If you look at this definition of range of f, and we look at the definition of surjectivity, we see that every function is usually surjective on the range of that function. Considering this definition and this definition, we see that any function is always surjective on the range. So instead of wondering much about what do you mean by this, simply look at the definition of the range of a function. If you understand this very well, then surjectivity on the domain means that the whole of the range is equal to the codomain of the function. Every function is surjective on the range of the function. So any function you give to me is surjective on its range. Okay. That's number one. Two, that second remark is that a function whose range is equal to the codomain is surjective on the codomain. So surjectivity on the codomain, if you know that the range of that function is equal to the codomain, then you have it for